Hello everyone, this is Akash. Welcome back to this YouTube channel Nursery with Lecture. In this video, I am going to discuss the second chapter in the differential calculus, that is a continuity and differentiability. Basically, this is a combined chapter, continuity and differentiability, where we will discuss how the function is in the closed and open interval. Basically, if we take a graph like this, between these intervals, how the graph is, whether it is continuous or whether it is differentiable, whether it is non-continuous, non-differentiable, all these things we will discuss in this chapter. Basically, these are all the important topics: continuity conditions, condition of differentiability, properties of continuity, properties of differentiability, theorems of differentiability, continuity and differentiability in an interval, finding differentiability points, as well as the points to remember. There are some points which we have to remember definitely. These are all the things I will be covering in this video. But before that, the previous videos, the limits I already completed. If you didn't watch those videos also, because limits is a base part for this chapter, because you have to understand the limits. What is mean by limit? What happens if limit exists? These are all the things you have to understand. So after watching this video, you can watch this video also. The link is given in the description. And if anyone didn't join the Telegram group, please join the Telegram group, because I am sharing their notes and the complete handwritten notes of every chapter, and also the MCQ questions which I am preparing for giving you to practice. All the questions are very important, because these are the questions which have the probability to come in the exam. So don't miss the chance. I prepared the Google form sheet, I designed the Google form sheet, and I kept the link in the Telegram group. So access those things, it is very important to you. And also in the previous sessions before the limits, I completed so many sessions, that is the very important topics where you can get easily 4 marks, like sets and relations, mathematical reasoning, statistics. These are all the topics which is very, very important to you while you are starting your revision or starting your preparation for JEE mains. So for this, the another chapter I am taking today is continuity and differentiability. We will see each and everything in this chapter, that is continuity, how the continuity is there, how the differentiability is there, whether it is continuous, how can we say the function is continuous, how can we say the function is differentiable. These are all the things we will discuss in this chapter. So let's get into this video. The first thing what we will going to discuss is continuity of a point. Continuity of a point. What does it actually mean? A function f of x is said to be continuous. Suppose if we take a graph like this, suppose f of x is a function. Suppose if we take the f of x as a function and f of x is continuous, what we can say? Suppose this is a point. This is a point a comma b. Suppose this is a point. How can we say this point after the function is continuous? So we have to do here one thing. Basically, what is the meaning of continuity? The continuity meaning is nothing but the LHL value, RHL value, and the function value at this point. Suppose this is a point. Suppose it is the value of 2. If we take the value of 2, that is x equal to 2 in a function f of x equal to function, the LHL part and RHL part must be equal. That is, the limit should exist. This is a condition of limit now. Limit should exist. And after the limit exists, after it must be equal to function value. So here it is actually a linking process. That is, for limits to exist limit, what we will see LHL equal to RHL. But here, to check the continuity, we will check LHL equal to RHL as well as the function value. Basically, these 3 things you have to remember. And also this LHL equal to RHL equal to function value, and it must be finite, not an infinite value. Suppose if we take tan inverse 1 by x and limit extending to 0, it is what you will get? You will get here 0. 1 by 0 is infinity. That is, if you take LHL, you are getting minus infinity, and if you take RHL, you are getting plus infinity. So these two are not equal, and these two are not also finite. So it is very important to check whether they are finite or not. So basically, if we see, suppose the graph is like this. If you see this point, it is an open circle, means the graph is here breakdown. This is discontinuous here. So what is the things you can infer from this? The main thing is to check the continuity at a point. It is very important for you. You have to check first limit exists or not. After checking the limit exists or not, you have to equate with the function value whether it is equal or not with the function value. If it is equal with the function value, you can easily say that the function is continuous. But if function value is not equal, you can say the function is discontinuous, like that. Now it is very important to see the continuity of point. We will say two things. Suppose if f of x is continuous, what we will say? Limit will exist now. Suppose in a question, if it is given that the limit is existing, the function is continuous. If they say like this, the function is continuous, what we can say from this? We can say from this the limit will exist. Definitely the limit will exist. But if limit will exist, can we say the function is continuous? No. It must be equal to function value. After equating function value only we can say that. So before that we cannot say. So basically these are the things you have to remember. If a function is continuous, it should be the limit should be exist. And if the function is if the limit exists, there might be a possibility that the function value may not be equal to the LHL and RHL. So you have to check. And also if f of x is continuous, the f of a, the meaning of this f of a is the function value at this point a is defined if f of x is continuous. But if f of a is continuous, the meaning the f of a is defined and it is well defined, and if it has a value, then we cannot say that it will be continuous. We have to check here. So basically what I am saying is there are two conditions. That is, if the function is continuous, definitely the limit will exist. But if limit exists, there might be a possibility that the function is not continuous. But if we take the second condition, if we take the function is continuous, then there definitely the function will exist, f of a will exist. But if f of a is defined and exists, there not be a reason f of x is continuous. There might be a possibility that f of x is not continuous because LHL and RHL will not depend on the function value. You have to take care of this. And next, there is an important thing, that is point functions. If we take the example of 1 minus x, that is 1 minus x and 1 plus x, if we take this example, it is very clear that 1 minus x greater than or equal to 0, 1 plus x greater than or equal to 0, x less than or equal to 1 and x greater than or equal to minus 1, minus 1, 1, greater, lesser. So these are all the point functions, because here what is the domain of x? What is the domain of x? Here the domain of x is, it is if we take the value greater than 1 in the x, the under root value is become negative. So we cannot take the greater value, that is not greater than 1. So we have to take the less than 1. What are the things less than 1? 0, minus 1. We have to take these things, that is minus, complete minus value. And here what we take? Plus values. So there is no connection between these and these two things. So basically this is the value breakdown of the function, and this is a point function, just a point. You have to assume like that, because at one point this function is satisfying, that is at x equal to 1. At x equal to 1, this point, this function is satisfying. So at x equal to 1, this function is called point functions. And you have to say the point functions are continuous or differentiable. These point functions are always continuous and differentiable. This is the main logic here. And the next thing we are going to discuss is continuity in an open interval. Continuity in an open interval. మనము ఒక ఫంక్షన్ అనేది ఈ విధంగా తీసుకొని ఆ ఫంక్షన్ కంటిన్యూస్ అని చెప్పాలి ఇన్ ఓపెన్ ఇంటర్వెల్లో అంటే మనం ఈ 2 ఎండ్ పాయింట్స్ని పక్కన నెట్టేసి మిగతా పాయింట్ మొత్తం చెక్ చేయాలి. ఎండ్ పాయింట్స్ దగ్గర కూడా చెక్ చేయాలి. ఏ ఫంక్షన్ f is said to be continuous in a, b. If it is continuous ఇన్ ఈచ్ అండ్ ఎవ్రీ పాయింట్. ఈ ఏ కమా బి పాయింట్స్ ఎక్స్క్లూడ్ చేయండి, ఎందుకంటే ఇక్కడ ఈ పాయింట్స్ అనేది ఫంక్షన్ డిఫైన్ లేదు కాబట్టి ఈ ఎండ్ పాయింట్స్ వదిలేసేయండి. కానీ ఈ ఎండ్ పాయింట్స్ పక్కన మిగతా పోర్షన్ అంతా చూసారా, ఆ పోర్షన్లో ప్రతి ఒక్క పాయింట్ చెక్ చేయాలి మీరు. అప్పుడే మీరు ఆ ఫంక్షన్ ఈ ఇంటర్వెల్లో ఏ విధంగా బిహేవ్ చేస్తుందో చెప్పగలరు. దీన్ని ఏమంటామంటే కంటిన్యూటీ ఇన్ ద ఓపెన్ ఇంటర్వెల్ అంటాం. నెక్స్ట్ మనం ఏం డిస్కస్ చేస్తామంటే కంటిన్యూటీ ఇన్ ద క్లోజ్డ్ ఇంటర్వెల్, అంటే ఏ కమా బి డిస్కస్ చేస్తాం. ఏ కమా డిస్కస్ చేసేటప్పుడు సపోజ్ ఇది ఒక గ్రాఫ్, ఈ పాయింట్ ఏ, ఈ పాయింట్ బి. మనం ఏ కమా బి డిస్కస్ క్లోజ్ ఇంటర్వెల్ డిస్కస్ చేసేటప్పుడు ఓపెన్ ఇంటర్వెల్ ఏం చెప్పాం, ఈ 2 చెక్ చేయాల్సిన అవసరం లేదని చెప్పాం. కానీ ఇక్కడ ఈ 2 కూడా చెక్ చేయాలి, ఈ 2 కూడా చెక్ చేయాలి. కానీ చెక్ చేసేటప్పుడు మనమేం గుర్తుపెట్టుకోవాలంటే ఒకటి ఇక్కడ ఈ పాయింట్ చెక్ చేస్తున్నాం అంటే సపోజ్ ఇక్కడ ఫంక్షన్ కంటిన్యూస్ కాదని చెప్పాలంటే మనం ఎల్హెచ్ఎల్ ఆర్హెచ్ఎల్ తీసామా, ఆ ఎల్హెచ్ఎల్ ఆర్హెచ్ఎల్ ఫంక్షన్ వాల్యూ ఎఫ్ ఆఫ్ ఏ కదా ఇక్కడ, అలాగే దీనికి కూడా ఎల్హెచ్ఎల్ ఆర్హెచ్ఎల్ ఎఫ్ ఆఫ్ బి తీసామా. కానీ ఈ ఫంక్షన్కి లెఫ్ట్ సైడ్ గ్రాఫే లేదు కాబట్టి ఎల్హెచ్ఎల్ మనం తీయాల్సిన అవసరం లేదు, డైరెక్ట్ ఆర్హెచ్ఎల్ ఫంక్షన్ వాల్యూకి ఈక్వల్ అయితే చాలు. ఇక్కడ రైట్ సైడ్కి గ్రాఫ్ లేదు కాబట్టి ఆర్హెచ్ఎల్ లేదు, ఇక్కడ ఎల్హెచ్ఎల్ జస్ట్ ఎఫ్ ఆఫ్ బీకి ఈక్వల్ అయితే చాలు. కాబట్టి క్లోజ్డ్ ఇంటర్వెల్లో ఈ విధంగా ఉంటుంది ప్రొసీజర్ మనం తీసేది. మనం ఏం చేయాలంటే దాని పరంగా వెళ్ళాలి. ఇప్పుడు అసలు ఒక ఫంక్షన్ అనేది ఎందుకు డిస్కంటిన్యూస్ అవుతుంది, కంటిన్యూస్కి రీజన్స్ ఏంది, కంటిన్యూస్కి రీజన్స్ ఏంటంటే లిమిట్ ఎగ్జిస్ట్ అవుతుంది, ఎల్హెచ్ఎల్ ఈక్వల్ టు ఆర్హెచ్ఎల్ అవుతుంది, అది ఫంక్షన్ వాల్యూ ఎఫ్ ఆఫ్ ఏకి ఈక్వల్ అవుతుంది అని చెప్తాం. కానీ ఒక ఫంక్షన్ డిస్కంటిన్యూస్ ఎందుకు అవుతుంది, రీజన్స్ ఏంది, డిస్కంటిన్యూటీ రీజన్స్ ఏం కావచ్చు, ఫస్ట్ది ఎల్హెచ్ఎల్ నాట్ ఈక్వల్ టు ఆర్హెచ్ఎల్, ఇదే కదా ఫస్ట్ ఫార్మోస్ట్ రీజన్. సెకండ్ ఎల్హెచ్ఎల్ ఈక్వల్ టు ఆర్హెచ్ఎల్ బట్ ఇట్ ఈస్ నాట్ ఈక్వల్ టు ఫంక్షన్ వాల్యూ. అండ్ థర్డ్ LHL equal to RHL. Suppose there are 3 cases here. You have to think very carefully. That is LHL not equal to RHL is the first thing. Second thing, if LHL is equal to RHL but it is not equal to the function value. And the third case is LHL equal to RHL but the function f of a is not defined at point A. So the second case, what is the difference between second case and third case? Here LHL and RHL exist, here also LHL and RHL exist, but here f of a is defined, just not equal. But here f of a is not defined, so it should not be equal. And these are the 3 reasons. What are the 3 reasons? Maybe limit does not exist, and the second reason is if LHL equal to RHL but it is not equal to f of a, the limit of the value of the function. And the third one is LHL equal to RHL and f of a is not defined. You can definitely say like this. And next, now we have discussed the why the discontinuity is happening. We already discussed it now. Now we are going to discuss the types of discontinuity. In continuity chapter, it is very important because in continuity there are types of discontinuity. Discontinuity. What are the types of discontinuity is there? Basically, the discontinuity is of 2 types: removable discontinuity and non-removable discontinuity. This is removable. This is non-removable. Means we can remove the discontinuity by doing some things. We cannot remove the discontinuity. In this also there are types, that is missing point, isolating point. In this there are 3 things. The first thing is finite, second thing is infinite, third thing is oscillatory. So if you see discontinuity cause of 2 types, removable, non-removable. When it will be removable, it is very important. When the limit, that is LHL equal to RHL, limit exists, it is of removable type. And when LHL not equal to RHL, this is non-removable. Does not exist. Basically, it is all depend on the limit. If limit exists, it is of removable type. If limit does not exist, it is not removable type. And also, the removable type is divided into 2 types. That is missing point and isolating point. And the second one is Non-removable part, there are three parts, that is finite, infinite and oscillatory. These things you have to remember. And when it is a missing point removable discontinuity, when function is not defined here, but here function is defined, and when it is finite, when LHL equal to RHL, when LHL and RHL are finite, these things you have to remember. When it is missing point removable, when a function is not defined but limit exists but function is not defined, it is a reason for discontinuity na? So when we can say the function is discontinuous is nothing but for missing point discontinuity, the limit will exist but the function is not defined, and for isolating point the function is defined and it is not equal to LHL, that is the limit exists part. And now this finite type, for this finite type LHL equal to finite, RHL equal to finite, but they are not equal because the limit does not exist now. LHL are not equal to RHL. Okay, understand? And infinite type, the LHL is infinite and RHL is infinite, that is any one of them is infinite. It is completely infinite non-removable discontinuity. And if it is oscillatory, you can definitely see that sin x. What is sin x? Sin x is an oscillatory function. Suppose if we take the infinity part, whether it is 0 or -1 or 1, so we cannot specify a specific value. So it is very common that sin x is an oscillatory discontinuity is present in that. But sin x is always continuous, we already know. I am taking example how the oscillatory works. Oscillatory works is nothing but LHL and RHL. Suppose if we take the infinity, that is limit extending to infinity, what is the value of sin x? What is LHL? Infinity minus. Is it 1 or -1 or 0? Is it for RHL, is it 0 or -1 or 0? So we are not able to specify a specific value for LHL and RHL. So here what we can say, there are no specific values for LHL or RHL, whether it is 0, whether it is -1 or whether it is 1, we cannot say at infinity. So this is the main important thing here. And also in the finite type of discontinuity, that is LHL equal to finite and RHL equal to finite, and these thing in finite type there is a concept called jump of discontinuity. What is meant by jump of discontinuity is nothing but the difference of LHL and RHL. The difference of LHL and RHL is nothing but jump of discontinuity. Means at what value it is jumped to discontinuity. That is the meaning of this jump of discontinuity. Suppose if RHL is 3 and LHL is 1, what is the difference? Jump of discontinuity is 2. The meaning of this 2 is nothing but for less than the LHL to be less than RHL. The RHL is 3, the LHL is 1. So there is a difference of 2. So because of this difference of 2, that is the jump of discontinuity. Jump of discontinuity for difference of 2, we are getting the discontinuity type here. Discontinuity finite type. So this is the reason why we are calling it as jump of discontinuity. This is a part. And next. And next, if when we see in limits, I already explained a magical table. Here also there is a magical table. That is, if we take functions f of x, g of x, if we take these functions, if they are continuous and it is also continuous, then f of plus or minus g and f of into and divided by g, these all are continuous. We already know that. Continuous. And if f of x discontinuous here, discontinuous and it is continuous, the sum is always discontinuous. Sum is always discontinuous, but here may be continuous. May be continuous. And here it is continuity, it is discontinuity. Here discontinuity. Means f of x is discontinuous here. We are saying like that. Here it is discontinuity. Discontinuity. So here f of plus or minus g may be continuous. Important here. It may be continuous. It may be continuous. It may be continuous. So basically when we take two functions, that is f of x and g of x, and when we do operations on f of x and g of x, that is addition, subtraction, multiplication, division, and when these functions holds the property that these functions are continuous, 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 and discontinuous, continuous, these two functions will behave as discontinuous functions in arithmetic things, and in division and multiplication it will be maybe continuous. If one function is discontinuous and another function is continuous, it might have a possibility to behave like a continuous function. Suppose if we take an example of x and 1 by x, it is continuous function. What about 1 by x? Graph of 1 by x, 0 it is not defined. For 1 1, 2 means it is decreasing. For 1 1, for 2 it is decreasing. So the graph will be like this. And if you take minus 1, it is minus 1, and for minus 2, so this is like this graph. So you can say there is a discontinuity thing here. But when we multiply x into 1 by x, there is answer 1. What is 1? 1 is a constant value, that is point function. All point functions are continuous, so there might be a possibility to behave like a continuous function. So it is important thing. And now there is a theorem called intermediate value theorem. Intermediate value theorem. What is the definition of this is, I will read. If f is continuous in a comma b, suppose they are saying that there is a function like this, a comma b, between a comma b it is continuous, they are saying. If f of x is continuous at a comma b and f of a not equal to b, it means f of a value is not equal to f of b value. Yes, it is not equal here also. Yes, fine. Then for any value c, it means this is f of a, this is f of b. In between these two values, f of a and f of b, then there exists at least one value of c. Then it will exist at least one value of c, where if we keep x0 in that, if we keep x0, f of x0, it will become c. Understand? They are saying that in between f of a and f of b, there might be a value where, that is c. When there is a value of x0, it will be definitely c. It will definitely c. So in f of a and f of b, there will be a point, that is c. To get this point, there might exist a point, that is x0. If you keep this x0 value in a function, you will get the value of c. The meaning is like this. This is intermediate value theorem. And there is an application for intermediate value theorem. Suppose if there is like this. Suppose if we see this is a graph. What they said is, suppose if this is 1, and this is 2, what you can say, if f of x is continuous, and suppose if you take these points as a and these points as b, what you can say, if suppose this is a function, if we assume like a function, f of 2 is positive and f of 1 is negative. Suppose f of minus 1 is negative. It means f of 2 here f of 2 1 here, f of minus 1 negative. So if we do like this, that is upper function is positive, this here lower is negative. When we join, there must be a point. That is, there must be a root for this equation. So this intermediate value theorem helps us to find that root. It is very important. The statement is like this: if f of x is continuous in a comma b and f of a dot f of b, here f of a is positive, f of 2 is positive, f of minus 1 is negative. When you multiply these things, you will get negative. And when you get negative, then there exists definitely a value, because you cannot connect a value, you cannot connect these 2 points by not going along like this. Without touching the x-axis, you cannot go and join these 2 dots. It is difficult now. So you have to touch the x-axis. Means you have to cross the x-axis. It means there might be a reason to have the root. That is, there is a reason. There is a root here. And next, a continuous function whose domain is some closed interval, must have its range also in closed interval. So you can definitely say that, what is the domain of sin x? R na? What is its range? -1 to 1. Suppose this is R, minus infinity comma infinity. If this is a range, this is domain, there is definitely the closed interval for range. They are saying like that. So this is a reason, and there are key points. You have to just listen. If f is continuous and on 2 and 1 1 on a comma b, then f inverse is also continuous. Suppose if we take a graph like this, this is function is continuous. That means this function is bijective. It has 1 1 property as well as onto property. So in the line y equal to x, this curve will behave like this. Means this is a graph. This is a graph of inverse of this function. Suppose this is f of x function. This graph is f inverse x function. Means if f is the function and it is 1 1 and onto, it is a bijective function. And if a function is 1 1 and onto, if it is a bijective function, then there exists its inverse, and the inverse graph is symmetric about y equal to x line. This is the thing you have to remember. And how to calculate the points of continuity? How to calculate continuity points? How to calculate continuity points? You have to see. Suppose if there is point like this, 1 by root of 1 minus x, you have to see when it is not obeying the rule, that is 1 minus x equal to 0, at x equal to 1, this function is getting wrong. So at x equal to 1, there might be a chance this function is discontinuous. So you have to check like this. So by this you can calculate the continuity, whether it is at what points it is continuous. And also there are some points to remember. I mentioned in the last. Those points are all polynomial, trigonometric, and the remaining functions which are restricted to their domain. In their domain they are always continuous. You cannot say they are discontinuous. They are always continuous. At what? At their domains, not in the remaining domain. If we see domains, it is very important. Suppose if we see 1 by x, what is its domain? Its domain is r minus 0. So in r minus 0, in a remaining except 0, the remaining all place it is continuous except 0. So this is a polynomial function. So this is a polynomial function. So you can assume a thing here, that is r minus 0. R minus 0 is nothing but except 0, all the remaining points are included here. So that is the reason here. And it is continuous everywhere except 0. Because 0 is not present in the domain, this function is always continuous. We cannot say it is discontinuous at 0. Yes, it is discontinuous at 0, but the domain is not there now. This function does not hold 0 as their domain. Why you are discussing at 0? There is no point to discuss here. So there is no point to discuss that 0 is present in this domain. 0 is not present in this domain. So except that domain part, what are the remaining values in domain? Those values are always continuous at that points. You have to remember like this. And also, suppose if there is a fractional part x, like this function is there. Suppose f of x is a function. Suppose if we keep this in a fractional part, this fractional part where it will break at integers na. So you have to check at what points f of x is getting integers. So at that point there might be a possibility, definitely the function is discontinuous. And also if we take the greatest integer and if we take g of f of x, at what points f of x is getting integers? At what points the f of x is getting integers, you can say that at that point you will get points of discontinuity. It is like this. And also here signum of, suppose if you take signum x graph, f of x graph, what is signum x graph? This is a signum x graph na, here dark, here like this. Is it correct? For positive value it is positive na? Okay, it is correct. Like now it is correct. Okay, now it is correct. See, for all positive values it is like this, and all negative values the graph is like this. So what you can say, the continuity of sigma x should be checked at the points where f of x is equal to 0. Here you can definitely observe that at only x equal to 0 point you are observing the sigma x is 0 and the graph is breaking. You can observe. So you can say that at what point sigma x is getting 0. That is, if suppose if we take sigma x square minus 1 equal to 0. If we take this is a function, if we assume this is a function, at what point the sigma x is getting 0, x square plus 1, x square minus 1 equal to 0, x equal to plus or minus 1. Is it true? Yes. At x equal to plus or minus 1, this function is getting, at x equal to minus 1, this function is getting what? At x equal to minus 1 and also x equal to 1, this function sigma x getting 0. So at 0 you can say that the function breaks and the function is discontinuous. You have to check the sigma x values. So now this continuity part is completed. Now discuss the differentiability. How can you say a function is differentiable? Differentiable means it should have the slope, means we can differentiate that function. Suppose if we take this parabola, is it differentiable? Yes, it is differentiable everywhere. We can differentiate the curve at any point. What is the minimum basic requirement to check the whether the function is differentiable or not is the function at any point it should have the unique tangent. It is a main condition. Suppose if we take this point, it has a unique tangent, and next point it has a unique tangent, but at the same point there are no two tangents, only one single tangent. So this curve is said to be differentiable curve. And we can differentiate and we can find the slope of this point. Understand? And also if we see, suppose if we take the mod x curve, this is a mod x curve. If we observe at the point 0, there is a tangent like this, and if we observe at point 0 again from this side, there is a tangent like this. So at a single point there are existing two tangents, which is not accepted. So this mod x is not differentiable for 0 at x equal to 0. Remaining 0, it is all differentiable. Like that you have to say. And what is the condition for differentiability? The condition for differentiability is right hand derivative. We have to derivate it. That is limit h tending to 0 f of a plus h minus f of x, f of a plus h minus f of a divided by h. This is RHD. Next LHD, left hand derivative, that is limit h tending to 0 f of a minus h minus f of a divided by minus h. These two values must be equal, that is LHD equal to RHD. If these 2 points are equal, then we can definitely say the function is what we can say? The function is differentiable. And now this is called the first principle. In the previous video, that is, I already explained root 101. Root 101, if we say it is solved, we can find the root of this equation with the help of the first principle, that is f of a plus x equal to f of x plus f dash x into h. This is the first principle we use it to find the square root of this. Root 101 we can find like this. So basically it has many uses. We can check the differentiability condition, as well as we can find the errors. We can use the error and we can find the corrective value here. So this is a thing here, differentiability. And there is a shortcut. What is the shortcut? Is to find LHD, that is left hand derivative and right hand derivative. We can directly differentiate the terms. Suppose if we see mod x can be opened as x if x greater than 0 and minus x at x less than 0. if we have to check whether mod x is differentiable at 0 or not, we can directly differentiate these things. X, what is the differentiation? 1. Minus x, differentiation is minus 1. So 1 to minus 1 is not equal. So this function is not differentiable at x equal to 0. We can say like this. The meaning of this is the shortcut. We can directly differentiate the function parts as it is without substituting, without thinking anything. We can directly differentiate these things and we can get some values. We have to check whether these values are equal or not. If these values are equal, the function is differentiable at that point. If these values are not equal, we cannot say that the function is differentiable. It is not differentiable. And differentiability also. There is a table. Same table repeats for limits, continuity as well as the for differentiability. What is the table actually? This is a table. This is a function of f of x, this is a function of g of x, and this is a f plus or minus g into x, and next this is f into divided g, anything like this. Now if f of x is differentiable, g of x is also differentiable, these two will differentiable. And if it is not differentiable and it is differentiable, you will get differentiable, you will get not differentiable, and it is maybe differentiable. Maybe. And if you get this as non-differentiable and these also non-differentiable, this is may be differentiable, this also may be differentiable. This is a table you have to understand. Very important table. By remembering the things in this table, you can definitely solve so many questions. It is very important for you. And now there are some theorems in differentiability. You have to learn those theorems. So what are the theorems? I will read and I will explain to you. If f of x comma g of x are differentiable at x equal to a, okay, two functions we are taking, that is f of x and g of x are differentiable at x equal to a, then f of x plus the theorems is nothing but these only. The differentiability theorems is nothing but these only. If f of x is differentiable and g of x is differentiable, then there will be a differentiable function for combined equation, that is f plus or minus gx, and f of x divided g. So basically these are all the things. So this is the things you have to remember. And also finding differentiability in an interval. How to find the differentiability points? Basically I will read and explain. To find differentiability in an interval, if you want to find the differentiability, we first look for possible points. I already said at what points you are getting the doubt whether this function will exist or whether this function is defined or not. Those points you have to check definitely in the interval. And also we have to apply LHT and RHT for those points to check the differentiability. For each point you have to apply LHT and RHT. But you can see definitely the step function, that is greatest integer function and the fractional part function. Where the integer comes, there definitely there is a discontinuity, and if the function is discontinuous, it is not differentiable. We can say like that. All the possible points of discontinuity, also possible points of non-differentiability. It is fact. Suppose this is a graph. This is a graph. It is not continuous in these points. So it is not differentiable in these points also, na? Not differentiable and also non-continuous. If the function is non-continuous at a point, then it is also non-differentiable at that point. This is a theorem 1. And also the last thing is modulus function is non-differentiable at 0. So for mod f of x, what we can infer here, if mod x equal to 0 is not differentiable, not differentiable. At which point? At x equal to 0. Okay. So at whatever function will be in the modulus operation, what we can say, this f of x is not differentiable for all points at at f of x equal to 0. Suppose if we take like this, x plus 2, suppose this is mod, this function is not differentiable at x equal to minus 2, because at x equal to minus 2 this mod is getting 0. So at what value the mod is getting 0, at that point there will be a chance of getting what? Non-differentiability. So this is a complete chapter of continuity and differentiability. Now we will discuss some of the questions. Which are really important. I will discuss very less questions because I have to give time to you in order to revise and do the problems of your own, not by me. I can explain as many as problems you want, but the main reason here is I can explain the things. I can give the glimpse of the topics here, and I can give the glimpse of the problems, how to solve. Suppose if there is a problem, I listed down 3 problems. I listed down. I will explain one problem which give an impact of 10 or 20 problems. So if these problems you listen carefully, you can solve the remaining 10 problems. It is like that. Basically the first question is alpha 1 minus x sin x plus beta cos x plus phi divided by x square. X less than 0. X equal to 0. 1 plus gamma x plus delta x cube divided by x square whole power 1 by x if x is greater than 0. See, they are asking alpha plus beta plus gamma plus delta. These points they are asking. See here, f of x equal to this thing. అంటే వాళ్ళు ఏమంటారు అంటే ఆల్ఫా ఇంటూ 1 మైనస్ ఎక్స్ సైన్ ఎక్స్ ప్లస్ బీటా కాస్ ఎక్స్ ప్లస్ 5 ఈక్వల్ ఎక్స్ స్క్వేర్. ఇది ఎక్స్ లెస్ దాన్ 0 ఉన్నప్పుడు ఫంక్షన్ ఇది. అంటే ఇదేంటి, ఇప్పుడు లిమిట్ మనం ఫస్ట్ ఈ ఫంక్షన్ అనేది 0 దగ్గర కంటిన్యూస్ అని చెప్పాలంటే ఫస్ట్ లిమిట్ ఎగ్జిస్ట్ కావాలి కదా. అంటే లిమిట్ ఏంది, లిమిట్ ఎక్స్ టెండింగ్ టు 0 మైనస్ లిమిట్ ఎక్స్ టెండింగ్ టు 0 అంటే ఎల్ఎస్ఎల్ పార్ట్ మనం తీసుకుంటాం ఆల్ఫా ఇంటూ 1 మైనస్ ఎక్స్ సైన్ ఎక్స్ తీసుకుంటాం అంతే కదా, ప్లస్ బీటా కాస్ ఎక్స్ ప్లస్ 5 తీసుకుంటాం డివైడెడ్ బై ఎక్స్ స్క్వేర్ తీసుకుంటాం. ఇప్పుడు దీన్ని ఎలా సాల్వ్ చేయాలి, హౌ టు సాల్వ్ దీస్ ఈక్వేషన్? వీ కెన్ యూజ్ ద ఎక్స్పాన్షన్స్. దట్ ఈస్ ఫర్ సైన్ ఎక్స్ ద ఎక్స్పాన్షన్ ఈస్ x minus x cube divided by 3 factorial plus x power 5 divided by 5 factorial. Depending on that lower thing we have to decide. So you can, here the x is enough. Here for sin x the x is enough. For cos x 1 minus x square by 2 factorial plus x power 4 by 4 factorial. So here also 1 minus x square is common. 1 minus x into, for sin x what is the possibility? For sin x there is only x is possibility because there is an x cube which is not that much useful, plus beta into cos x we got 1 minus x square by 2 plus 5 divided by x square. If you see clearly, when we multiply alpha inside, alpha minus x square alpha plus beta minus beta x square by 2 plus 5 divided by x square. If you observe clearly, if we combine the x square terms, what you will get? Minus alpha minus beta by 2. This thing over. Next what you get? Alpha plus beta plus 5. Is it correct? Divided by x square. What we are checking? Limit extending to 0. If we clearly see, the denominator is x square and the numerator is x square. So it must be the minus alpha minus beta by 2. It must be equal to the value of this limit. That is 3. That is minus alpha minus beta equal to 3 and also alpha plus beta plus 5 equal to 0. It should be alpha plus beta equal to minus 5. So when you do these things, that is minus 2 alpha minus beta equal to 6. When you substitute here, when we add, you will get minus alpha equal to 1 and alpha equal to minus 1. One value you got, that is alpha equal to minus 1. When you substitute in this, alpha equal to minus 1, beta what you got? Beta equal to minus 4. So alpha equal to minus 1, beta equal to minus 4. These two things we got. Now you have to solve this thing. You can observe this limit extending to 0, 1 plus gamma x plus delta x divided by x cube whole power 1 by x. When you observe this what is this thing? Limit extending to 0, you can definitely observe that this is 1 power infinity problem. When we apply 0 here, you can definitely see 1 power infinity. So what is the form we have to apply in order to solve the 1 power infinity form? That is e power e power limit extending to 0, 1 plus gamma x plus delta x cube divided by x square minus 1 into 1 by x, minus minus cancel, and this x will be multiplied here and x cube will multiply. So basically this limit is existing, means delta equal to 3 we got, and this gamma must be 0. So here we got alpha, beta, gamma, delta. What is alpha? Alpha minus 1. Beta what is? Minus 4. Gamma 0. Delta 3. So what is the answer here? Answer, what is the answer? Minus 2. So minus 2 is the answer for this. Understand? And also here there is a slight wrong here. You can see here when the limit exists, that is delta. So e power delta is the answer. E power delta is the answer, and e power, this gamma is 0. This gamma is 0, nothing but this gamma is 0. E power delta. So like this, what we got? Alpha equal to 1, alpha equal to minus 1, beta equal to minus 4, e power delta that equal to 0, gamma equal to 1. This is the answers for these 4 things. These 4 things, alpha, beta, gamma, delta. You have to solve like this. This is the only question I am going to discuss here, because the remaining questions which I listed down are the same type questions. So discussing those questions is meaningless. So this one problem, what you will understand, you will definitely see there is a partition, that is 0, 0, 0. So we have to check at 0 how the function is, whether it is differentiable, whether it is continuous. What we have to check? We have to check first continuous. If your function is continuous, then definitely it will be differentiable. So first, in order to check the continuous, we have to check the limit. So we checked the limit LHL and we equate that with the function value. So in order to test the continuity, and next we find out the RHL and we equate it with the limit value, that is function value, that is at x equal to 0, the function f of x, how it is behaving. F of 3 means f of x at x equal to 0, how the function is behaving. So when we use x equal to 0 in this equation, that is f of 0, we will get answer is 3. So by using these 3 answers, we are getting the values like this. So it is very important to do these problems of these type of problems. I completely given the problems in the Google form, that is nearly 20 problems. Please do those problems also. So this is the chapter, and after this differential calculus, in the what we are discussing, continuity and differentiability, this here. Now we discussed continuity and differentiability. So this is very important. You can definitely see why I am highlighting like this. The reason behind this is every shift in JEE Mains, a question will become in this chapter. From this chapter, every shift will have a question. So thoroughly revise this chapter. If you didn't understand, watch this video twice, or you can revise the notes which I am providing in the Telegram. So join the Telegram group and access the Telegram channel, where you can get the notes as well as the problems for practice. So that's it for the video. If you like this video, subscribe to this channel and also hit the bell icon. Thank you.